Hi everybody. So today we're going to be doing notes on section 9.1. This is our first day of our new unit, Unit 7. So we're going to be learning all about solving functions, solving quadratics this unit in different methods. But first and foremost, before we get into that, I want to go over some review on how to simplify radicals, because that's going to be really useful as we go through this unit. So first thing I want you to do is go ahead and simplify each of these. I'm going to do, just simplify each of these. So push pause, and then when you're ready to check, push play. Go ahead and check your work for each of those. So 5 squared is just 5 times 5, which is 25. Negative 12 squared, notice that the negative is inside the parentheses, so it's saying this whole quantity, negative 12, is what's squared. So negative 12 times negative 12 is positive, because a negative times a negative is a positive. Versus this one, the negative sign is on the outside, so it's negative, and then the 12 squared. So the negative stays out in front. We're just squaring the 12. It's really important that you understand the difference between these two and the placement of the negative sign. All right, now go ahead and write down your definition of the square root. So square root is when we say the number a is a square root of b if a squared is equal to b. So for example, 4 squared is equal to 16, and negative 4 quantity squared is also equal to 16. So what this means is that 4 and negative 4 are square roots of 16, because we can square both numbers and it gives us positive 16. All right, what we want to do now is simplify some square roots. So I'm going to do these with you, and then you'll try some on your own. So the square root of 49 is, if you said 7, you are correct, because 7 times 7 is 49. Now part B, notice we have a negative sign on the outside. So a negative is going to stay on the outside with our number. And what is the square root of 36? If you said 6, you are correct. And that negative stays out in front because it was in front of our radical. The next one, what is the square root of 121? If you said 11, you are correct. And this plus or minus is written in front of the radical to start, so it stays written in front of our answer. Now this fraction is a little bit different. This is like saying the square root of 1 divided by the square root of 25. So the square root of 1 is just 1, and the square root of 25 is 5. So you just split it up into 2 pieces. All right, now these are the ones that I really want to focus on. The others are pretty straightforward. They're perfect squares, very straightforward. But these, 27 is not a perfect square. So let me write a little note for what we're going to do with these. So when it's not a perfect square, you have to find perfect squares within it. And I'll show you what I mean. So 27 may not be a perfect square, but 27 is equal to 3 times 9. And 9 is a perfect square. So 9 is a perfect square. Perfect square. and then this 3 is left over. So when I write my answer for this, the square root of 9 is 3. And then what's left underneath the radical is the 3. And then this 3 that's out in front was the square root of 9. So let's do another one. 48 is not a perfect square, but let's see how that breaks down. So 48, the first thing that comes to mind for me is 8 times 6. Some of you may look at that and think 2 times 24 or 12 times 4. So it'll work if you do different numbers, but I'm going to choose 8 times 6 because that's the first thing that comes to mind. Now, neither of those are perfect squares, but they both still break down further. So 8 breaks down as 4 and 2, and 6 breaks down as 2 and 3. So now I have 4 as a perfect square, and then I have another perfect square, this 2 times 2. That's also 4, so that gives me another perfect square. And then this 3 is the little lonely guy that's left over at the end. That is not a perfect square and will not come out of the radical. So let me write a little note. These multiply to 4. So it's a perfect square. Squeeze that on there. So when we write our answer, the square root of 4 is 2 times the square root of 4 again is 2. And then what's left underneath the radical is the 3. So this 3 is the leftover. And then this 4 gives me one of the 2's, and then the other one gives me the other 2. So my final answer will be 4 rad 3. All right, now I want you to try 2 of your own. And I want to point out part B, that plus or minus that's out in front, the only thing that's going to do is in your final answer, you'll write a plus or minus in front of your answer. All right, so go ahead and push pause, and then when you're ready to check your answer, push play. All right, go ahead and check your answers for these 2. Now, an important thing that I want to point out is there is more than one correct way to do these. So for example, 24, the first thing that came to mind for me was 6 times 4, but you may have also chosen to do 12 times 2 or 8 times 3. Same thing with 72. 9 times 8 is the first thing that comes to mind for me, but you may have thought of different numbers for yours instead. For example, if you had done 36 times 2, 36 is a perfect square and you could have stopped. You wouldn't have to draw your little tree down any further. So I really want to stress to you that there is more than one way to simplify each of these radicals. This just happens to be the way that I did it. Also, did anybody notice what I missed on the answer for part B? You said the plus or minus. You were correct. I forgot to write it. All right, I want you to try 2 more on your own. So try part C and D. So push pause, and then when you're ready to check your answers, push play. All right, go ahead and check your answers for C and D. Again, there's more than one way to do these, so you're just checking if your final answer matches mine. For part C, there wasn't an obvious number that went into it other than I know 2 has to go in because it's even. And when I divided that, 2 goes in 64 times, and I lucked out. 64 is a perfect square. Versus part D, 54, the first thing that came to mind was 9 times 6, and 9 is the perfect square. Now I want to point out, for part A, 6, I broke that down further as 3 times 2, versus for part D, I just left it as 6. The reason why for part D I left it as 6 is because I already know that's not going to break down any further and give me any other perfect squares. So I'm just going to leave it alone and leave it as 6. For part D, you may have also not recognized that 9 and 6 goes in, but see that it's even and broken it down as 2 times 27, and then factor 27 even further. So let me actually go ahead and do that over here on the side. So 54, it's even, so we know 2 goes in, and 2 goes in 27 times, and then 27, I know breaks down as 9 times 3. So 9 is a perfect square, and at the ends of all of my little trees, I have a 2 and a 3 left over. So what comes out of the radical is the square root of 9, which is 3. And then underneath the radical that stays stuck is the 2 times 3. Or in other words, 3 rad 6. So there are truly lots of ways of doing these problems. Speaking of problems that have lots of different ways to do them, I'm going to show you an example with the square root of 200, different ways of doing this. So some of you may look at this, and the first thing that comes to mind is 200. Well, that's 2 times 100. 100 is a perfect square, and I'm left with 2 on the outside. So the square root of 100 is 10, and then what's left underneath the radical is 2. Or you may look at the square root of 200 and think, well, I know that 50 goes into that, and 50 goes in 4 times. But then 50 breaks down even further as 25 times 2. So my perfect squares are the 4 and the 25. And then what's left over at the bottom of my little trees is 2. These, by the way, when I keep saying these little trees, I'm talking about the little lines that I keep drawing to see how things factor further. So the square root of 4 is 2 times the square root of 25 is 5. And then what's left underneath the radical is 2. So this is 10 rad 2. Same answer, 2 different ways. Let's do it again. Let's do, or I'm going to show you one more way to do it. Let's say you look at this and go, well, I know that 25 is going to go into this. And I know that 25 goes in 8 times. Think of it like quarters. Like that's $2.25. So 25 goes in 8 times. But then 8 still breaks down further as 4 times 2. So my perfect squares are 25 and 4. And then my leftover little lonely guy is the 2. So then what's outside of my parentheses is, outside of my radical is 5 times 2. And then the 2 is left over inside. And we get 10 rad 2. And I want to point out, these last 2 options that I did are really, really, really similar. But notice I started with different numbers. This one I started with 50. This one I started with 25. But the actual tree diagram part of it that I drew looks really similar. So what you'll start to recognize when you simplify these problems is you'll start to get a better idea of recognizing what your perfect squares are within it from the get-go. So for example, this one, square root of 200, I would automatically choose 2 times 100 because 100 is a perfect square, and I know I'm not going to have to do my tree diagram any further. Versus one of these options would be a lot more work. Or like for number 54, or sorry, for the square root of 54, I did 9 times 6 because I know 9 is a perfect square versus doing 2 times 27. And if you're struggling with how to find what goes into them, goes into the numbers, for example, the 54, you can just use a calculator. So do 54 divided by 2. So your tree can be 2 times 27. Or 54 divided by 3, your tree could be 3 times 18. Or 54 divided by 4 does not go in evenly. 54 divided by, I know 5 is not going to go in. So divided by 6, that goes in 6 times 9. So you could look at that and go, okay, well, 6 and 9, 9 is a perfect square. I'm going to pick that option. So you can use a calculator to double check as well if you're not sure what numbers go in. But a really good sure way of figuring out what your little tree options can be is if it's even, you know 2 goes into it. And if it ends in 0 or 5, you know that 5 goes into it. So you always have at least a starting point. All right, that is the end of our notes. Have a good rest of your day.